The tutorials in introductory physics are a research-based student activity developed by the University of Washington's Physics Education Group. Students in the tutorials work in small groups to complete worksheets based on common student difficulties. CU Boulder has used the tutorials in recitations since 2003. Student groups are facilitated by faculty, graduate teaching assistants, or TAs, and undergraduate learning assistants, or LAs. Learning assistants are students who have taken the course in the past who are hired to help facilitate student learning. The LA program was first developed at the University of Colorado Boulder in 2001. In this video, we will share recommendations for effective facilitation of the Washington tutorials. Most of these recommendations are applicable to a wide variety of student group work.
My primary suggestion is trust the students. These tutorials are very well designed, and when students are arguing and maybe getting things wrong, you have to listen.
I think one of the most important things I've learned is just kind of hang back more than you think you should at some points and let them work through problems. I found that when I jump in too quickly, then they haven't really solidified their own ideas, so they're very unsure. And when somebody does come to the correct answer, they're very quick to just agree rather than argue it through. Typically, when I hang back and just watch for a little bit longer, they argue things out and they really come to form a solid idea on their own. And then that's easier to build off of, even if it's an incorrect idea.
So we have the school.
Right.
And it also has some force going this way. So there's no difference, really.
We all have a tendency to want to jump in and correct errors, and I think the tutorial really is designed to help the students self-correct if given the space. Now, that doesn't mean ignore them. You have to listen, and when the students, for instance, are self-satisfied and moving on, but in fact haven't understood, that's a great moment to swoop in and ask an appropriate question.
Choosing the appropriate questions is one of the biggest challenges for many teachers in the tutorials. Telling students the right answer can short-circuit the learning process. Some questions that often work well are, "Can you explain your thinking here?" Or, "I see you disagree. What's going on there?" Or, "What do you think is happening?" Or, "What did you draw for that diagram?"
So, can I get you guys to draw 2 free body diagrams for me? Keep questioning, because they generally have the idea or are pretty close. And so if you keep asking them about it, and they start to actually explain their thinking or explain where they're coming from, they generally get it.
Yeah, it goes like more and more towards the direction you pull it. So I feel like it would spin and it would come like straight towards where you're pulling it.
And that's where it really helps to have prepared it beforehand, because then you really know the questions in and out, and then I might have to just directly say, well, there's something you're missing. And then they really have to sit and puzzle. Sometimes I'll have to say, well, what about X? What about there's gravity? And then a lot of times, because they've thought about it already, they can see, oh, gravity, I didn't even think about that.
It's important not to get stuck with groups because everybody needs your help. It's important not to annoy students. So this is a flip side of Socratic questioning. Students find the tutorials can be very frustrating.
A lot of times when people come in for the first time, they're very taken aback because it's very much not the typical lecture style, the typical recitation style where you just go through problems. There are definitely some students who are not fans.
This is not the way they normally are taught, and they're not being told if they're right or wrong, and they're not being told answers. So there is some emotional aspect to the tutorials that it's important for the TAs to be thoughtful about. Sometimes I will sit down with students and say, I'm not going to tell you the answer, but I guarantee you by the time we're done, you're going to know the answer.
It's very important to be very patient with the students. And as much as you're able, never get angry, never even give a hint that you're putting them down.
You're faced with something new and you feel kind of like, this isn't what we did in class, and I don't know how to solve this problem. And I think our TAs have done a good job of kind of introducing concepts in the very beginning of class and saying, watch out for this is a little bit different than how you've been taught, during your lecture. And I think that has actually helped quite a bit.
Last semester, the last page of the exam, it was based on the tutorials and it was purely conceptual as opposed to just being the normal Scantron. So then students saw a benefit to it. It gives them something to look for and a reason to do them.
So you have to believe in them. What I mean by that is that when you first institute something very different like this, it is likely that you will get some complaints. Some students are just confused. This is not the learning environment that they were expecting. And so you as a faculty member cannot let them smell fear. So I now will say things in my large lecture class on the first day and throughout the semester that connects my class to the tutorials and that praises the tutorials in some realistic way. It's not false praise. So I would encourage faculty to be consciously thoughtful about the pedagogy of the tutorials so that they can help their students to take advantage of them. I wrote a web page once upon a time when I was teaching the course in Physics 2. I called it a frequently asked questions page. And it's why won't my TA tell me the answers? And why won't you publish the answers after we're all done, and all the things that concern students and that are difficult. And so I explained why I thought it was unproductive or counterproductive to tell students the answer. Relatively few students have indicated they ever went to that webpage, but faculty members love that webpage, especially a faculty member who's just about to institute the tutorials and is wondering those things themselves. So I think, again, finding resources that help you to understand the mechanisms by which a tutorial works.
But once they get used to them and how it really helps them when they get to the exam and they're like, oh, I remember this from tutorials, I understand this now, then they start to like them more and be more engaged. One of the strategies I've learned is just to be excited about it, because I think physics is really cool. That's why I've done it so many times. I love it. And so just to kind of show them that this is something that's really cool and it's real world. And then they finally have that aha moment where they really understand it and they get it for the first time. And that's always really rewarding as an LA, if you help them get to that aha moment. Their acceleration of students covering that distance.
Oh, I see.